right, so I'm going to do two more problems. I'm going to do 195 and 199. So number 195, it says in the following exercises, identify the roots of the integrand to remove absolute values, then evaluate using the fundamental theorem of calculus part 2. So what this is saying, and one of the reasons that I'm going to do this, is what I'm trying to do is prove to myself where this thing is going to be positive and negative. So we know the absolute values give us these V's, right? The problem with the V's is sometimes these V's are not always above the x-axis or always below the x-axis, correct? Sometimes you've got the x-axis running through them. So by going ahead and figuring out what our zeros are or the roots are, we can figure out whether we've got a positive or a negative. So what this is going to do is it's going to help me set up what my intervals need to be. And I am going to use part 2 here of the fundamental theorem of calculus, so much easier than using part 1. So let me go ahead. Let's do a new share. Let's do our whiteboard. So number 195, we have the interval from -2 to 4 of t squared. Nope, we don't either. Yeah, we did. T squared minus 2t minus 3 dt. So the first thing that I'm going to do is I'm going to do some algebra with the original function, this t squared minus 2t minus 3. So if I take, let me stop my phone from ringing. So if I take t squared minus 2t minus 3 and set it equal to 0, I'm going to come up with, actually, let me do this in a, so if I factor it, because this one's really factorable, pretty, it's negative, so t minus 3, t plus 1 equals 0. If I break it apart, set each part equal to 0, I'm going to have t equals 3, t equals -1. So something's going to happen when I'm 3 and -1, those two values, something happens with my function. It's either above or below the x-axis, and we're going to figure that out. So I'm going to do me a little chart here. Now this chart looks like what I did for the first derivative test. Again, we've not taken a derivative. I'm just trying to figure out, is my function, the actual function, above or below the x-axis? Because what that's going to tell me is whether the area is positive if it's above, or if it's negative if it's below. So I've got -1 and I've got 3. So I'm going to do some test values here. I'm going to let x be a -2, let x be 0, and x be 4. And what I'm going to do is I'm going to plug it in. Now notice I don't care about the absolute value. All I know is the absolute value gives me the V shape. I'm going to plug this into t squared minus 2t minus 3. I'm going to figure out, is it positive or negative? So if I plug -1 in, I'm going to have -1 squared, which is 1, plus 2. No, excuse me, if I plug -2 in, sorry, -1's going to give me 0. If I plug -2 in, -2 squared is 4. -2 times -2 is 4. So that's an 8. 8 minus 3 is +5. This is a positive on this side. If I plug in 0, I love plugging in 0, I'm going to get -3, so that's a negative. And then if I plug in 4, 4 squared is 16, minus 8 is 8. 8 minus 3 doesn't matter, it's positive. Okay, so what this has done is this has helped me figure out how I'm going to break up my intervals. So my intervals are going to run from, now notice I'm going to start from -2 and I'm going to end at 4. So my interval is going to run -2 to -1 because that's positive. This is going to be t squared minus 2t minus 3 dt. Notice from 0, or excuse me, from -1 to 3 is going to be negative, so I need to subtract that area out. So I'm going to have the integral from -1 to 3 of t squared minus 2t minus 3. To erase some stuff here, let's get rid of all this. We know from 3 on it's positive. We can only go as high as 4. So dt, and then I'm going to add, because it was positive, the interval from 3 to 4 of t squared minus 2t minus 3 dt. Okay, so now that we've got our integrals that are set up, let's go through and actually integrate. So notice we're going to get the same integration for every single one of these. So if I take the integral of t squared minus 2t minus 3, that's going to end up being, oops, why don't you let me right here? Let me annotate. Oh, there we go. That's going to end up being t cubed over 3 minus t squared over 2. Notice the 2's are going to cancel out. I'm just going to be left with t squared and then minus 3t. And that's going to be evaluated from 2 to -1. I'm going to subtract from that. Again, guys, it's the same thing for every single one of them. So this is going to end up being t cubed over 3 minus t squared minus 3t evaluated from, now this one's -1, 2, 3. And then we're going to add to that, same thing, t cubed over 3 minus t squared minus 3t evaluated this time from 3 to 4. So the problem again with this one is notice that my picture here. Notice that my integral or my interval was from -2 to 4, and I had a sneaking suspicion that it was going to change signs between -2 to 4. So I'm subtracting out where it's below the x-axis and adding in where it's above the x-axis. Guys, you could have also seen this from graphing it. You would have seen that what's happening here. So now I'm just going to go through and I'm going to plug these values in. Remember, for each set that I have to go through and do the upper bound minus the lower bound. So you're going to see me do this math quite a bit. Guys, if I go through and plug -1 in, I'm going to have -1 over 3 minus 1 plus 3. That's going to end up being 5/3 if you go through and do the math. And then I'm going to subtract from that the -2. So if I plug -2 and I've got -8/3, -2 is going to be 4. So minus 4 or plus 6, that's going to give me minus a -2/3. So it's going to be plus a positive. Then minus because it's below the x-axis. Guys, I'm going to assume that you're okay with plugging 3 and -1 into this statement. If I plug -3 and -1 in, notice -1 is going to give you the same thing it did on the other one. So really, I just have to plug the 3 in. That's going to be -9. And we've got minus 5/3 because, again, it's the same thing. And then guess what? We're going to add to this. If I plug 3 in, I'm going to get the same thing. 4 is going to change. That's going to be -20/3 minus -9. By the way, of course, -9 is also plus a positive. So our statement's going to end up being, that does not look like a plus. That looks like an F, doesn't it? So that's a plus 2/3. So I'm going to do 5/3 plus 2/3, which is 7/3, minus whatever -9 minus 5/3 is, and then plus whatever -20/3 plus 9 is. If you do all that math, you do end up with a positive 46/3. So there was more of the graph above the x-axis than there was below. We did subtract out the below. All right, cool, guys. So that's it for this one. Or no, we didn't subtract it. We just had to change the sign of it, or it would have subtracted out the total area. There we go. All right. So I'm going to look at number 199. That'll be the last problem we do on this section. Oh, so I think I need to go back. Let me do a new share screen. All right. So 199 is a word problem. That's the reason I wanted to do it, because I love word problems. So 199 says, suppose the rate of gasoline consumption over the course of a year in the United States can be modeled by a sinusoidal function of the form 11.21 minus cosine of pi t over 6 times 10 to the 9th gallons per, what's our MO, per month. What is the average monthly consumption, and for which values of t is the rate at time t equal to the average rate? All right, so the first thing that we have to do is we've got to go in, we got to figure out what is the period pi t over 6, because I don't know what the period of that is associated with. So that's what I'm going to do first. Let's do a new share. Oh, come on, share. So our function was on 199. 11.21 minus cosine of pi t over 6 times 10 to the 9th. So in part A, let's go through and find our period. So your period, remember, is 2 pi divided by whatever period that you're showing or whatever you're taking the cosine of or sine of. So my period in this case is going to be 2 pi divided by pi over 6. And ironically enough, when I divide by pi over 6, the pi's are going to cancel, and you're really doing 2 times 6, which is going to be 12. That's so cool because we're talking about in terms of months. How many months is in a year? 12. So this formula has been set up to function in terms of 12. So the integral for our thing is going to go from 0 up to 12. That's what our integral is going to be. So if that's the case, if my integral is going to go, my function 11.21 minus cosine pi t over 6 times 10 to the 9th is going to go from 0 to 12. Guys, remember 12 is going to come back around, right? It's forming the whole entire circle. This is all trig stuff, but it's forming the whole entire circle. But if you think about cosine of 0, the cosine of 0 is going to end up being it's going to go to 0. So here, what ends up happening is because it's going to 0, my answer is really just going to be 11.21 times 10 to the 9th, because that piece here goes to 0. Because it's repeated itself. That's what I'm trying to say. It's repeated itself back up to where everything, if you take the integral of it, I'm not even going to take the integral of it, but if you take the integral of it, since we're going from 0 to 12, that's the period, the top piece and the bottom piece are going to cancel each other out to be a 0. So the cosine, if you're taking the whole entire period there from pi t over, or from 0 to 12, because of the pi t over 6, it's canceled itself out. That's what I'm trying to get across to you. Okay, so we're trying to figure out when is the consumption equal to it. So in other words, I want to figure out when is cosine of pi t over 6 equal to 0. And to do that, I just need to go through and actually solve that. You can punch it in on the calculator to solve it. Take the r cosine of 0, multiply by pi over 6. If you do that, you're going to get t equals 3 and t equals 9. So at 3 months and at 9 months is when it's going to be equal to 0. So in other words, at 3 months is when I'm starting the down portion, and then at 9 months is when I'm starting the up portion. All right. So part B, since I've not got this pulled up anymore, what is the number of gallons of gasoline consumed in the United States in a year? So if I want to figure out what the number is consumed in a year, basically I'm going to take this number here, right? This number here was the monthly consumption, and I'm going to multiply that number by 12. 11.21 times 10 to the 9th times 12. I needed to write that. That's monthly consumption. I think it's average monthly consumption. ABG, average, MONTHLY, consumption. So the yearly consumption, if you multiply that by 12, is going to end up being 1.35 times 10 to the 11th. So that's yearly consumption. And then on part C, write an integral that expresses the average monthly U.S. gas consumption during the part of the year between the beginning of April, which is t equals 3, and the end of the year, which is t equals 9. Guys, there's a reason they're using those values. It's because that's what we figured out was when it equals 0. So we just want to write our integral for this. So here's how this is going to work. The only part that we're going to be taking the integral of is that cosine of pi t part. That's even though that kind of comes in as this statement here, it's the cosine of pi t over 6, which is affecting the actual graph. So here, I'm going to actually, it's going to look really weird. I'm trying to figure out the best way to write this. I'm going to pull my 10 to the 9th up front. So I'm going to have 10 to the 9th times 11.21 minus, and then I'm going to do 1/6. See, I'm pulling that 1/6 out. I'm going to take my integral from 3 to 9 of cosine of pi t over 6, and then dt. And I'm out of room, guys. So what I'd have to do is take the integral of cosine pi t over 6. Oh, no, I don't, because I pulled the 6 out. That 6 is not there. It's out front here. I just have to take the integral of cosine pi t. And the integral, of course, is going to be sine. So you're going to do sine pi t, and then plug your 3 and your 9 in. If you do that, you end up with, because I'm so out of room. So if I plug stuff in, and I think I've already done some subtraction here, I'm going to end up with 10 to the 9th times 11.21 plus 2 pi, or 2 over pi. And that ends up giving you an answer of 11.84 times 10 to the 9th. So part C it's a really, really weird way of setting this up. We have not set one up like this. It's just really, really weird to look at it. I wanted to make sure, and I'm not a fan of this problem. I don't like this problem. I think it's more confusing than helpful. It is neat seeing the fact that with cosine, your period's 12, so that's why we end up canceling that out. That it's neat seeing that graphically speaking, that's the reason that goes to 0. And it's neat seeing that it's 3 and 9 months. But then the rest of this, to me, it gets a little confusing. So again, I wanted to do it just in case you saw something like this on your homework. But anyways, that's it for this section. Come back and we'll do more.